Hello again, this is Math 2231, remote delivery for April 14th. And this is part 3 of today's delivery. And we're going to be talking about the properties of the definite integral. And we're going to be doing some calculations. Please make sure you use these if you have to take some notes of a YouTube page. And sometimes I will be suggesting you do this to check your understanding. So let's begin with some properties. The first property for today is the integral from a to b of f of x dx is equal to the negative of the integral from b to a of f of x dx. If you think about the definitions, you'll kind of come to this conclusion. That means the delta x's are all negative. We can interchange the limits on any definite integral, and it introduces a minus sign. I will often do this in calculations, both here and in other calculus courses that I will teach. So be aware of this property, please. Number 2, the integral from a to a of f of x dx is equal to 0. Well, what that means is the area under a single point is going to be 0 because there's no width. So if the upper and lower limits are the same, the answer is 0. Number 3 says the integral from a to b of c times f of x dx is equal to c times the integral from a to b f of x dx. Well, this follows definitely from the fact that the definite integral is a limit after all. And whenever we're taking the limit of a constant times a function, we can jerk the constant through the limit sign. That's what we're doing here. So whenever I'm doing a definite integral, I can jerk the constant through the integral sign. You can factor out the constant. Number 4 also follows from the work we did on limits. If I'm taking the definite integral from a to b of f of x plus or minus g of x dx, that's the same thing as doing the integral of from a to b of f of x dx plus or minus the integral from a to b of g of x dx. That means we're doing this term by term, just as we do with any limit. This next one is a little more complicated. The definite integral from a to b of f of x dx is equal to the definite integral from a to c of f of x dx plus the integral from c to b of f of x dx, where c is any number. Now, as it says, this property is more important than you at first might realize. And one of the main uses is to tell us how we can integrate a function over adjacent intervals. Sometimes there will be a singularity, and there will be other reasons that we'll do this. But note that c doesn't need to be between a and b, although if it is between a and b, it's probably even more obvious as to why it is true. The last property that we're going to discuss in this segment is the definite integral from a to b of f of x dx is the same as the definite integral from a to b of f of t dt. You see, the point is this t is a dummy variable. It could be x, it could be t. It doesn't affect the answer. But the thing that matches is the t here with the dt here. Okay, so example 2. What I want you to do is use the results from the first example to evaluate the following. And the first one, remember that we calculated the definite integral from 0 to 2 of x squared plus 1 dx was 14 over 3. So hit pause, and let's see how you do. See how you do. Well, here we just changed the changed the limits of integration from 2 to 0 and 0 to 2, so that's going to be negative 14 over 3. Here we had a factor of 10 that we pulled out, so the answer is just going to be 10 times the 14 over 3, or 140 over 3. And here we did the first problem again, just with t being the independent variable, and we get 14 over 3. Here is a second problem. I want you to evaluate this definite integral, and it looks very formidable. Please press pause, do the problem, and return. Let's see how you did. Well, that has to be 0 because we're integrating from 132. 130, and that is a continuous function over that interval, so that does apply. Let's look at this. Now I give you some values of certain unknown functions, f and g, but I do tell you what some other definite integrals are. I ask you to use these facts to determine the value of this integral. Please hit pause, work the problem, and we'll see how you did. Let's see how you did. Well, what we're going to do is break the integral up into different pieces. We're going to go from minus 10 to 6, and we're going to go from minus 10 to 6 this way. Now we can factor out the 10, and we can factor out the 2, and so now what we need to do is continue the calculation. Now this one is known to be actually going from minus 10 to 6 is known to be minus 23, so if I go from 6 to minus 10, that is 23. And similarly over here, I know that this going from minus 10 to 6 of g of x was minus 9, so I plug in all the numbers and I get 44. Let's do another example. Please pause, capture the problem, work it, and then we'll see how you did. Let's see how you did. Well, first of all, we're going to break this up, and we're going to use the hundredth value because that's something that we know about. So this follows from that last property because 100 is a different point, and so I can use that as this place and this place to have this. This is the final property. But then what we're going to do is some of these we know, some of these we don't know. We don't know this one, for example, but we're going to break this into two things that we do know. This one, so we're breaking this one into this plus this, and we're using minus 10 as the point. So now what we have is this one is going to be the negative of this value that we know. This one is going to be the negative of a value that we know, and this one is going to be negative 6. I do all the calculations and I get minus 12. Make sure you understand this example. Now, more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now more than ever, take care of yourself and others.